There are three types of radioactive decay: alpha decay, beta decay, and gamma decay. Learning about these forms of nuclear decay is a crucial part of any nuclear physics course. I am Pauline Moyaerts, I'm a Belgian nuclear medicine resident, and in this video I will go over each specific form and explain it as simple as possible. Let's start with alpha decay. Alpha decay occurs when a nucleus emits what's called an alpha particle. An alpha particle is a combination of two protons and two neutrons, which, if you know your periodic table, you will recognize as a helium nucleus. The process is fairly easy to understand in terms of the mass and properties of the resulting atom. It loses 4 from its mass number, 2 from the protons and 2 from the electrons, and 2 from its atomic number. This means that the original atom becomes a different element after undergoing alpha decay. The alpha particles are often very energetic, but because of their massive size, they cannot travel very far before they lose their energy. They have a very low penetration power, and because of this low penetration power, alpha particles are easily stopped by a sheet of paper or the outside layer of the human skin. And they are only a potential health concern if they are ingested or inhaled. Alexander Litvinenko is a famous example of this. He was poisoned by polonium-210, an alpha emitter. The alpha radiation damages DNA and creates lots of very reactive free radical ions that can do further damage. One specific result is a reduction in your white blood cell count, which, apart from anything else, can make you more susceptible to infection and requires blood and platelet transfusions. The liver, kidneys, spleen, and bone marrow are particular targets and are massively damaged by the alpha radiation. The rapid damage to the gastrointestinal tract causes nausea and vomiting. Bone marrow failure can result in days. One other target is hair follicles. This is why Litvinenko lost almost all his hair before he died. Alexander is not the first casualty of polonium. In 1956, Marie Curie's daughter died of leukemia that she is believed to have contracted through exposure to polonium years before. The second type of decay that we'll discuss today is beta decay. Beta decay is a process in which atoms emit beta particles. Beta particles are electrons with high energy. They are much smaller than an alpha particle, which means that they can travel further before being stopped. But they can be stopped by a layer of clothing or a sheet of aluminium foil. Equally, its small size results in its ionizing power being considerably smaller than that of alpha particles. This stems from the fact that the human body is mainly made up of empty space. The smaller the particle, the lower the risk of it colliding with parts of an atom, which in turn lowers the risk of damage. Beta decay occurs when an atom has either too many protons or too many neutrons in its nucleus. There are two main types of beta decay. Beta plus decay is when a proton turns into a neutron with the release of a beta plus particle along with an uncharged, near massless particle called a neutrino. As a result of this process, the daughter atom will have one less proton and one more neutron than the parent atom, but the overall mass number will remain the same. Beta minus decay is essentially the opposite process of beta plus decay. During this process, a neutron turns into a proton with the release of a beta minus particle and an electron antineutrino. Because of this process, the daughter atom will have one less neutron and one more proton than the parent atom. Negative beta decay is far more common than positive beta decay. In a process known as brachytherapy, beta radioisotopes can be used to irradiate areas inside a patient to prevent the growth of certain cancers. The emission of beta particles is also used indirectly in the medical scanning technique known as positron emission tomography. Fluorine 18, one of the several isotopes that are routinely used in PET imaging, decays by positron emission, resulting in stable oxygen 18. The nucleus of fluorine 18 is unstable as it is proton-rich. As such, a proton converts to a neutron and emits a positron or a beta plus particle and a neutrino. A positron or beta plus particle is an antimatter particle which is similar to an electron but has a positive charge. The third type of decay that we'll discuss today is gamma decay. What separates this type of decay process from alpha or beta decay is that no particles are ejected from the nucleus. Instead, a high-energy form of electromagnetic radiation, a gamma-ray photon, is released. Gamma radiation is part of the electromagnetic spectrum, just like visible light. Humans cannot see gamma rays because they have a much higher frequency and energy than visible light. As well, gamma radiation is unique in the sense that undergoing gamma decay does not change the structure or composition of the atom. This type of radiation is able to penetrate most common substances, including metals. The only substances that can absorb this type of radiation are thick lead and concrete. Since it penetrates so easily, gamma rays are widely used in medicine and specifically in the area of oncology to treat malignant tumors. Gamma rays are employed as a gamma knife consisting of multiple concentrated beams of gamma rays that are focused directly onto a tumor to kill the cancer cells. Gamma rays are also used to preserve food in the same way as they are used to sterilize medical equipment. Cobalt-60 produces low amounts of gamma radiation, which kills bacteria, insects, and yeast, while otherwise causing no significant changes in the food's content. Here's a quick summary. In alpha decay, the nucleus loses 2 protons. In beta decay, the nucleus either loses a proton or gains a proton. Both alpha and beta decay change the number of protons in an atom's nucleus, thereby changing the atom to a different element. In gamma decay, no change in proton numbers occurs, so the atom does not become a different element. Radioactive decay can damage living things. Alpha decay is the least damaging, and gamma decay is the most damaging. Thank you so much for watching this video. If you liked it, please give it a thumbs up.